In this presentation, we're going to be looking at how to explore the urban experience of federal architecture through eye tracking emulation software. Now, we find that science is beginning to confirm on multiple levels the adage coined by Winston Churchill: we shape our buildings, thereafter they shape us. Now, some estimates are suggesting that people living in developed countries and cultures spend upwards of 90% of their lives in buildings. Such long exposures in and around the built environment is undoubtedly going to affect our human health and well-being, either in positive ways or negative ways. Now, with all of this, there's a growing body of research and insights are coming from neuroscience, cognitive science, psychology, evolutionary biology. It's all suggesting that the built environment plays a critical role in shaping our human cognition, our behavior, and emotions. And some studies are showing that our attractiveness is a key element in how this built environment affects our well-being. So if I'm attracted to a certain building, that will affect my health. Now, a case in point is the classic 1984 study by Roger Ulrich, which concluded that a patient's view through a window looking at nature actually reduced recovery time from surgery as opposed to a view of, say, a brick wall. And so as human beings, we're attracted to certain things, and they affect us in different ways. Now, we know that half of the sensory information going to our brain is visual. Now, when we're confronted with anything that is visual in nature, our brain has to quickly determine if it's threatening or if it's rewarding. Now, these quick judgments of visual information lead us to make what we call approach-avoidance decisions. And as a result, there's also a hormonal and bodily response. So when we experience something visually, aesthetics, a building, etc., that affects us in different ways. So take example, this scene, right? Which of these two images could be perceived as threatening or stressful? According to neurobiological research, experiences of beauty and their feelings of pleasure, reward, and satisfaction are located in a different part of the brain than experiences of the sublime and their associations with awe, fear, or terror. Now, according to Semrzecki and Yal Resner, they suggest that we seek the beautiful, those things that are beautiful, in order to nourish our emotional brains. And what they found through various studies is that beauty is experienced in a certain part of the brain known as the field A1 of the MOFC, whereas something that's sublime is experienced in a different part of our brain. Now, when we consider the impact of U.S. federal buildings and architecture on the public realm and its effect on health, well-being, are there certain design elements or features that tend to capture our human attention, or are we attracted to better than others? Now, a recent 2020 visual preference survey conducted by the Harris Poll and the National Civic Art Society suggested that there might be such a preference. And so in this study, they looked at pairs of different federal buildings. They showed two instances, and they asked, which of these two buildings would you prefer for a U.S. courthouse or federal office building? Now, the survey respondents, in looking at these, they overwhelmingly responded, 72% of Americans responded that they preferred traditional buildings over modern looking architecture. And this was irregardless of political, racial, ethnic, gender, socioeconomic preferences. Irregardless, there was a large majority that preferred the traditional building. So our research question in all of this was why? Why was this the case? And so our hypothesis in all of this was looking at, can a building, in our brains, we have what's called first glance vision. That first glance is our unconscious brain. And if we see something visually in the first 3 to 5 seconds before we actually make a judgment of sorts, which building would hold our unconscious attention, right? Which buildings are we attracted to without kind of that bias coming in? And so if that is the case, then that should have an effect ultimately on a decision that we make in the after 5 seconds in our post-attentive visual processing, which is what the Harris Poll survey actually was. Now, our second hypothesis was taking those results and looking at, okay, well, seeing the Harris Poll, then our hypothesis number 2 would be traditional buildings will have the ability to hold our visual attention on a greater capacity than the modern ones. And ultimately, this is a claim that using a software of such, where we're using eye tracking emulation, can affect, right, the outcome of how people are going to experience and result. And so there could be a correlation between these two, this data. So our methodology, what did we do to get there? So first off, let's talk a little bit about visual attention software. Now, we wanted to look at these buildings and what's their ability to attract and hold our visual attention. So we use 3M's visual attention software. It helps us analyze the same paired of images of federal buildings used in that Harris Poll. And because the software combines real biometric data, such as eye tracking experiments, with an artificial intelligence algorithm, we're able to predict with 92% accuracy where people will look in that first 3 to 5 seconds, right? Their unconscious brains, where, what is holding their attention. So let's explore this with this slide. Now, that was up for just a short amount of time. So what do you remember about those two images? Which of the two would you prefer? Was it the one on the left or the right? Now, that image was up for 3 seconds, just enough time for our preconscious brain to process. Now, what this software allows us to do is to predict where most of you may have looked in that first 3 to 5 seconds. Now, what the software does, it spits out a number of reports that we're able to analyze. A heat map, it spits out hotspots, gaze sequence, and areas of interest that catalogs various visual elements. So if we took that same image, we ran it through the software, this is what the reports would look like. So what we're doing in this is we're using a pair of images, similar to other studies by Labdus and Salingaros. We're using this software to investigate the visual competition and interaction between the two buildings as a single scene. Such a test would enable us to see the qualities of engagement between these two buildings. And it's very similar to A/B testing, but using the VOS software to evaluate the preference for us using this objective data. So here's an example. The heat map provides a visual mapping of where attention is landing. But then we need to translate that to a numerical value. So we used another software called ImageJ. It's put out by the National Institutes of Health, and it allows us, in a similar methodology as other researchers, to map the exact footprint or area of those buildings, and then compare those with the actual percentage of the heat map that lands on the building itself, where we can get percentage from that. So 76 versus 70. The second report is more self-explanatory. We're looking at the quantity of hotspots and the percentages. The third report, the gaze sequence, we're basically counting the number of spots that land on a building. And the area of interest, we're creating a more specific rectangle around those buildings to find out how what percentage is holding our attention. And then it spits out a report kind of like this. So in all of those, we take those findings of those different VOS reports, and we create a collective what we call the visual attention coherence score. And with that, we compare that then to the Harris poll results. So let's look at the results of the study. So pair one, this is the one we've kind of been looking at so far. We've got two federal buildings. Now, when we look at this, we find that the traditional building has a higher percentage than the modern one in its coherence score, as well as the Harris poll results. Pair of buildings number two, we find a very similar result, even though modern and traditional buildings are flip-flopped. We find that on the right side that it's the traditional building that once again has a higher visual attention coherence score compared to the Harris poll. Image pair number three, we also find a similar result. The traditional building wins on both accounts for the software and the survey participants. Pair number four has similar. The traditional building still wins, and in some regards by a large margin. Now, pair number five is where we start to get a little bit of difference. We find that the modern building actually has a higher visual attention coherence score than the traditional building. But this one, the Harris poll survey participants did prefer the traditional building over the more modern one. Pair number six, we find similar results. We find that the modern building has a higher visual attention score, and the Harris poll had the higher score for the traditional building. And some of the reasons for this might be the modern building has a tinted glass and those contrasts, color contrasts, and things like that. Pair number seven, however, does go back to that pattern that we saw earlier, where the traditional building does in itself lead with percentage score with the visual attention coherence score, and the Harris poll results won as well over the modern building. So let's discuss these results really quickly. How do these results compare? We find that the Harris poll, all of the traditional buildings did win. When it came to the software, the eye tracking emulation, we find that 5 out of the 7, it won. And so what did we do to analyze these? We used several non-parametric statistical tests to test those hypotheses that we talked about early on, as well as the claim. These are the various variables that we tested. So the statistical test of the first is that a building can grab our pre-attentive unconscious attention, and as a result, it has a higher an effect on our post-attentive conscious vision. And this proved to be true. This was statistically significant. Now, the second statistical test was running on each of the specific tests, the reports that came out of the software, and we found that this was true for the Harris poll. It was statistically significant, as well as 2 of the 4 VOS report categories. And so that's an interesting find there. The other statistical test was the claim, right? Can this software, is the Harris poll correlated, right, to the software results? And what we found that it was only true in regards to the 4th report with the area of interest. That was statistically significant, the others were not. And so note that we're dealing with a small sample size of only 7 image pairs. So maybe a higher, larger sample size would result with a more significant row outcome. So the conclusion with all of this: the future of medicine, argues Dr. Esther Sternberg, is focused on person-centered health, whereas the future of healing spaces and buildings, right, should be focused on person-centered and place-centered well-being. And so the major takeaways from our study with this paper is that the software can be used as a pre-designed tool. Let's say you're testing a rendering on, how's this going to be perceived when it's actually built? We can use it in those regards. We also find that buildings do grab our unconscious attention, that first glance vision in the first 3 to 5 seconds. And it can be related to our conscious decisions after the fact. We found that several of the statistical reports were significant that we mentioned earlier. And so all in all, we go back to our saying by Winston Churchill, we do shape our buildings and they do shape us. They do have an effect on us. And so in the age of democracy and thinking about federal buildings, right? These buildings do affect us in different ways and affect our health. So we should keep that in mind as we're designing those as architects and planners. Thank you.